Hi, Keith Van Wimmer here. Today we're going to talk a little bit about launch bags. I have some fiber characterization to do, and so I was pulling out some launch bags, and so I just want to talk a little bit about these, and then we're going to get into repairing them and doing some splice-on connectors. So a launch bag is nothing more than basically some form factor, whether it's a bag, of actual bag, canvas bag, or some kind of little miniature pelican case. They really only consist of some partial jumpers, and then inside of these, if you take it out, back inside here is just a reel of bare fiber. This is undyed 250 micron bare fiber. And it's just some way, some shape or form put into some sort of case with some connectors on it. They have multiple purposes. They have one purpose is that they move the front end of the OTDR out to the first connector. So we get in this one, this is 150 meters, so about 450 feet. This moves that front end out to that patch panel. What that allows us to do is fully characterize that first connector in the panel. They also have another really important function, which is basically protecting the front end of your equipment. So if you damage an end on a on a launch bag, you can repair that. And some of the methods we can do to repair is replace the jumper. These again, just take this out, replace the jumper. You can do a splice-on connector. This guy here is a splice-on connector. What we're going to do and show you how to do those. So there's all kinds of different methods. The bag that's kind of in my sights right now is this guy here. He was being used during training, and somebody damaged the connectors, and so we did kind of an emergency repair, which is just spliced on a couple ends, pigtails. This is fine. These splices here, even if they were theoretically high loss splices at half a dB, they're buried inside of this bag. In other words, the loss is calculated in the bag. That loss, the connectors, etc., in your OTDR would be disregarded. You set up your OTDR to say that your launch bag is 450 feet. So the only place that it's going to test from is this end connector out into your span or link, whatever you're testing, okay? So this guy here, he just sits in a bag, a little splice case here. This is just basically a little Corning splice case. It's been beat because, these bags aren't very, they don't offer any protection to the, to this. It's kind of, I don't know if you can see it, it's pretty dented up. So what we're going to do is these guys here, the cords have actually been repaired quite a bit. So what I'm going to do is I'm going to take this cord and cut it in half. These connectors are bad. I mean, this one will pass an inspection, but it's got a couple little dots on there, and I don't want to put that into my OTDR and possibly damage my OTDR connector or end face. So we're going to cut these off. Cut this in half. I'm going to splice this into there, and then we'll put on a couple splice-on connectors and clean this whole bag up and make it look almost like new. Maybe not this, but the rest of it will look pretty new. All right, so I'm going to go ahead and splice this on, and then come back and we'll put this all back together and put on some connectors. So I'm back from splicing on the pigtails, dressed them in here. So we did have to kind of cut some of the silicone, so just using some flush cutters just kind of nipped that so I could kind of lift it up and get fiber out from under there. So just be careful when you're pulling the fiber out. You also want to just make sure that when you're doing this, you're watching your bend radiuses and not getting anything too tight. I use polyester tape to hold the bare fibers down and just kind of keep things in place. And then I'm not gonna do anything with the put new silicone or hot glue or anything on there. So the next step that we're going to do is put on a splice-on connector. So using the same splicer, what I'm using for a splicer here is an NO. This is a View 1. It's an active clad alignment splicer. So rather than aligning on the core, it's aligning on the outer diameter of the clad. These things are really amazing splicers for the price. They come with a kit that has all the things that you need to put on the splice-on connectors. We have a universal splice-on clamp here. This is so that you can put the connectors in there. The other thing that we have to do is reconfigure the oven. So a lot of times when you have other splicers, on my VanTek splicer, I have to undo a bunch of screws and move things around and stuff like that. When we do this, to give it enough room to keep the ferrule body inside here, what we got to do is we have to redo the oven. So this guy, you just grab this and kind of pull it off and throw this one back in there, slide them in. There's some little grooves and a kind of a detent, and done. All right. In order to do the splice-ons, we need to have a splice-on connector adapter. And in order to put that on, we're just going to take our Phillips screwdriver, undo the one screw, take our universal clamp off, put this onto the alignment pins, and then just snug that down with the screw. Yeah. All right. So that's basically the hardware. We also have to do something in the software here. So once this boots up, we're going to go out of this, go over to our main menu, and go to our heater mode. And what we have to do is we're going to select our heat mode, or the 33 millimeter splice-on connector. It says SOC 3.0. Right, so that's a 3 centimeter, 30 millimeter splice sleeve, and that's the sleeve that is in here. So there's going to be a sleeve that sits at the back end of this connector here, and so they include that with the kit. Once we've done that, do make sure that when you, as with any splicing operation, that you have done an arc check on your machine to make sure that it's kind of tuned up for the environment and ready to roll and give you the best splices. So I'll be doing another video on this machine or the line to do splice arc checks. Just to be clear, again, VanTek Consulting, we don't take any kind of compensation. We're not endorsing anybody as far as paid endorsements. Everything that we endorse is our personal opinion. It's what we use in the field, what we've settled on. So basically, my shop is a Viavi shop as well as Inno. One of the reasons that I like Inno is a good value for the money. They're nice splicers. They're fast. They're easy. The splice-on connectors, these guys run typically, whether depending on the ones you're getting, run about anywhere from $25 to $17 each. So it's sometimes, they're a little pricey. One of the things with Inno is that their fusion or their splice-on connectors are $25, but that's for a card of 10 of these guys. So you get 10 connectors, $2.50 each. It's an amazing deal. You really haven't lived until you spent $25 on a connector and you mess it up, right? Twice or 3 times. That means that putting a connector onto this just cost you, anywhere from $50 to $75. Again, these guys here, good value for the money. So for this one, we're going to do on this connector, it's going to be an APC connector. Again, these connectors, if you're interested in these, I have a supplier that I deal with. They are a Rally Rep. They're based out of Salt Lake City. They're a great group of folks up there. Again, not a paid endorsement, but they're just one of the people that I get a lot of my materials and stuff from. They sell, splicers, Viavi test equipment, so they're kind of a good resource. So again, the only reason that these folks get a thumbs up from me is just because of their customer service. They don't pay me to say nice things about them. Trust me, if they weren't doing the job, they wouldn't get the shout out. Tell them VanTek Consulting sent you over. So this guy, again, he has a pre-cleaved fiber sitting in there. So you're going to put him into the universal holder and butt him right up. So this is going to get butted straight up to the end, to this part of the adapter. You got to put that right in. Close this. Bada bing, bada boom, done. Next thing we have to do is we have to put on the take the housing, I guess, off. We're going to take the clamp screw and we're going to put that onto the jacket. All right, take him, kind of push him in there, and then you got to work this jacketing up in between the two pawls, right? So that you can see that it's just in there and it's all lined up. Once you've got that, take your cap screw or clamp, whatever you want to call it, and put that on just a few threads, and now you can kind of keeps that guided while you're moving this down the jacketing. Once you get your jacketing up here, you can slide him down a ways and get him out of the way. Next one, make sure you get this guy on here. This is your splice sleeve. That's your shrink tube. There's a really tiny little strength bar in there. So make sure he's in there. If he sticks out, don't poke him with your finger because they're a little bit sharp. All right. We're going to strip off this jacketing and we're going to take it off with our 3mm. We're going to do about 1.5 inches here. That's too long for the cleaver, but what we're going to do is we're going to take this and we're going to do that for a reason. We want this aramid yarn. We want enough aramid yarn to make it all the way through to the other side because it's going to become part of our support here. All right, nobody said this was easy. Another inch off here. And keep your aramid yarn. You don't have to trim that off yet. Couple mil on your 900. Your 250. Plastic off. A little alcohol and that's clean. So holding this out, we're going to get that in. Make sure the 900's in as far as it will go. Cleave. Again, keeping this aramid yarn, don't get it too knotted up, but there's a little flyer there. Pop him in here. All right, at this point, give yourself one sanity check. Make sure all of your hardware's in place. All right. Close this. Hit the set button. Cleaves look good. Little alignment, arc. And we got a 0.02 splice loss across there. So again, I'm going to move my sleeve up here while it does the tension test. Now, when you take this out, since this has a little weight to it, it's going to drop, right? So you got to be careful with this. You want to make sure that we kind of don't bend it. So I'll hold it up in a vertical position, and then I'll move my tube down. Make sure that you get your tube all the way onto, and your aramid yarn is all the way onto and butted up against the body here. So that way we're going to get good support. You should have a mil or 2 or 3, maybe 4. of the 300. If you don't have this in here at that 300, you need to, well, continue on. You got to keep this. If you don't have that, you're not going to get the support you need. All right, so that's part of the learning. All right, so what we're going to do now is take this, hold all the aramid, and this guy just goes right into the oven and butts up. So once you're here, if you get a little gap right here, you just want to take this and kind of push him down. Tweezers will work. Make sure that he's right up against the body. Okay, once that's done, close your oven. Once this is cooked, remember that the jacketing here, since it's going to be heated a little bit, it's going to be a little soft, so you don't want to deform it, or you want to keep it as straight as possible. In other words, don't squish it and stuff like that. So, all right, once this is done, we'll take this out and let it cool. Okay, so it's completed the cook, so we're going to take this out. Again, we're just going to let this cool off for a bit. And this area right in here is a little soft, so you don't want to. You just want to kind of leave that in leave it straight, and again, don't pinch it or touch it. If you notice on our shrink, we got a good grip on here, and we got the aramid tied in right with the shrink tube onto this guy here, the little knurling. All right. So once this gets to a point where you're not going to burn your fingers off, just flip your aramid yarn down, take your snips, snip that off, throw it away. So that's our splice on. All right, we're going to let that cool a little bit, and then we'll put this on. So again, this body here, he's rectangular, and so it doesn't matter. You can, whichever side, it's going to fit onto the body. The body has little dogs on the side of it. Again, if you can see on here, I'll see if we can zoom in. There's these little dogs, and they align with these little tabs here with the holes in it, and that's what locks everything in. There's alignment grooves here. So when you're putting this on, one of the mistakes that happens is people tend to push on this and try and get it to go into here. And what it does is it flexes the splice because we're not fully supported. I mean, we're supported with the tube, but again, it's not, it's still a splice, right? So it's small glass. So what I found works best is just grabbing this and kind of pulling this up here. And I just leave that flopping around a little bit and just kind of guide him in. And then I just pull it in here using, grabbing down here and pushing up with my fingers. Once I get up here, align that with this point, right? So now this is where people want to push. They want to grab this and push it in. So what we're going to do is this is kind of a two-pronged approach here. We're going to kind of get that to start. And then gently, without putting any undue stress on, we're just going to kind of push on here, on this, and get it up there until it clicks into place. All right? Once you're done there, just tighten this guy up, and he pushes those pawls in and squashes against the 3 mil, right? So you can see down here where he's actually grabbed on and got the 3 mil, but he won't crush the fiber. All right. Once that's completed, throw on your housing. So this guy here, he has he lines with the chamfers on it. They shouldn't go on backwards. I'm not going to say that somebody can't do that, but you kind of would have to really force it on. So anyway, that goes on, and he just snaps on there, and we have a brand new, fresh connector. So now we've completed both ends of our splice-ons. We have a fresh, brand new connector on here. The final thing is to do an Otdr test on this. So I'll put one of my other bags on this connector, hook this to my Otdr, and shoot and be able to characterize both of these connectors. If this one has too much loss on the front end, I'll see that, or if it's broken or any reason, I would see that on the OTDR. It's not going to go out. If this one mated pair on the, I'll put my 1 kilometer launch bag on this guy, and we should have less than half a dB for the mated pair on there. Again, this is a wonderful way of putting on. It's cost effective. It doesn't take real long. You know, if you're not talking about it and making mistakes on camera, then you know you get through it pretty quick. Was getting ready to finish this all off, and then I figured, since I was testing this for myself just to verify everything, I wanted to make sure that I figured I might as well add this to the video. So what we're looking at, this is a T-Berd 6000 OTDR, well, frame with OTDR module on it. The other one, I didn't really like the way that the fiber was laid out in there and the silicone and all that stuff on there. So basically, I took all the fiber out of this and just recoiled some fiber and rebuilt the entire launch bag. So I made a new one in essence. We put on the connectors, so we have a couple little splices in here. We have our splice on connectors, and then I've got it linked up just to get, I want to know what this connector on the launch bag is doing. This is my far end connector, so I hooked it to another 1 kilometer launch bag, okay? So we've shot through that, and if you look at the OTDR trace, this is my launch, my initial launch, and I'm at 1310 nanometers at 3 nanosecond pulse width. So this is a I was going for 500 meters and I got 509. I can live with that. So no loss right at the front end. So that's the front of the OTDR here. And then as we come out, it gives us our loss for the span. So coming out, our 0 mark is now this connector right here. So at 1310, I've got a 0.004 loss across here, and it's showing the .33 for the overall attenuation and dB slope on the launch bag, that's a typical number for G.652. This box is SMF28, which is a G.652 class fiber. Everything came out good. It's all back in and set. So just watch when you put your covers on and secure those on. I'll probably use some of the polyester tape. So rather than using silicone and squirting that in there, making it difficult to dig out if I ever have to repair anything, I just use polyester tape, and that'll hold this stuff in. That's it. I mean, that's basically a launch bag. So all that's left is put it back in the actual bag, in the carrier bag, and all done. Alrighty, so I hope everybody enjoyed this. I hope you got something out of this. The splice on connectors, again, these are available through my friends over there at Rally Rep. Good people. Give them a call, give them a shout out, and tell them VanTek sent you over there. Again, no compensation for saying that. Just want to be clear. So hope everybody enjoyed this, got something out of it, learned something. And if you have any questions, comments, please leave them down in the comment section. If there's other videos you'd like to see, put that down there as well. And then, of course, all the YouTube stuff. Subscribe, like, all the usual stuff. Anyway, take care, be safe, and we will be back soon.